Hi everyone, we're just going to continue looking at these questions from the ChemSheets Kinetics booklet. So this is task 5, question 4, and in this question you're asked to use the data to find the order of reaction with respect to the reactants, in this case A and B, and then write a rate equation, calculate a value for the rate constant K, and then state its units. So let's look at how you can do that. Okay, so let's start by comparing some different sets of data. So to find the order with respect to A, we need to look for where its concentration changes. So that's here or here, but whilst the concentration of everything else remains the same. So you can see in that experiment and that experiment, B remains the same. The concentration of A increases by a factor of 2, and you can see that the rate increases by a factor of 2. So order with respect to, you often see with respect to abbreviated to WRT. So order with respect to A is first order. And let's deal with B. Again, we look for where the concentration of B has increased whilst everything else stays the same, while the concentration of A stays the same here between these two experiments, and B increases by a factor of 2, and we can see that the rate has increased by a factor of 8 over 2, which is 4. So B has increased by a factor of 2, the rate has doubled, so the rate has quadrupled, so the order with respect to B is second order. So let's write our rate equation. So we're going to write rate is equal to K, the rate constant, multiplied by the concentration of A, multiplied by the concentration of B squared, because it's second order with respect to B. Now let's calculate a value for K. Well, let's rearrange that. So K is equal to the rate divided by the concentration of A multiplied by the concentration of B squared. It doesn't matter which set of experiments you use, you're still going to get the same value for K. So I'm going to choose this bottom set. So the rate is equal to 16. I'm going to divide that by 2, multiplied by 2 to the power 2. Work that out, and it gives you a value of 2. So the rate constant is 2, and its units, well, rate is in moles per decimeter cubed per second. Concentration of A, moles per decimeter cubed. Concentration of B, moles per decimeter cubed squared. So there's 2 lots of that unit. That's going to cancel with that. So moles per decimeter cubed still on the bottom line. So let's add the powers together. So it would be moles to the power 2, but it's on the bottom line. So we're going to change its sign. Decimeters to the minus 3, let's add those together, that's minus 6, but it's on the bottom line, so we'll change that, and then the seconds to the minus 1.